Hello guys, Oscar Hotel 8 Sierra Tango November here from Survival Tech Nord. Welcome to the second episode of how to solar power your portable ham radio. Today we're going to be focusing on putting together an ultralight, ultra-portable power system for QRP rigs like the Elecraft KX2, KX3, the Icom IC-705, Lab599 TX500, the Zygu X5105 or the X6100, or the Yaesu FT-817 or 818. Now it's important to point out you don't have to use PowerFilm solar panels, although that's what I'm using. PowerFilm does support the channel and they are supporting this series. Of course, you should choose a solar panel which fits your requirements and your budget. No one's going to give you a hard time because you're not buying what I'm buying. Now, as far as portable power goes, we're talking about portable power for summits on the air, parks on the air, through hiking, preparedness, emergency communications where lightweight man-portable systems are critical. As we move through the series, we'll definitely get into bigger systems, for example, for contesting, for de-expeditions, for emergency communications, or even for powering your repeater or temporary fill-in gateways. With that said, stick with me, and I'll teach you what I know.
You are listening to the Emergency Broadcast Systems. This station broadcasts emergency news and official information on the air for assigned area.
Now, in episode 1, we talked a lot about receive current and transmit efficiency. These 2 points are always going to be our most important factors when choosing our solar power systems. In this clip, I'm operating the Icom IC-705 QRP on solar power. I've got the radio itself running at 10 watts. I've got a battery and charge controller, and I have a solar panel spread out near my operating location. A battery, a charge controller, and your solar panel are the 3 basic components making up your portable power system. Now, when you're connecting everything together, there's a certain order we must maintain. So the very first thing we want to do is connect our charge controller to our battery. Never connect the solar panel to the charge controller first. Doing so could cause an inrush of current, which could possibly damage your charge controller because there's simply no place for the current to go if the battery isn't connected. So, battery to charge controller, and then solar panel to charge controller. Those are the steps. One of the most asked questions from episode 1 was, how do I choose the best solar panel for my rig and equipment? There's quite a few different ways we could answer this question, but let's go ahead and keep it simple. The first way I like to do is tallying up all of the current consumption of the peripherals I'm using. My radio and, for example, my Microsoft Surface tablet or Raspberry Pi. Whatever that current consumption number is, the total current consumption for all of the peripherals, I'll choose a solar panel which meets or exceeds that current consumption number. Operating this way allows your solar panel to cover all of your current consumption overhead without ever touching your battery reserves. Simply put, as long as the sun is shining and your solar panel is deployed, your station will run completely off of solar power. Now, when we're putting together a portable solar power Go kit for our QRP rigs, it's quite easy to become distracted or lost in all the details. Now, in the current clip, I'm operating SSB with the Icom IC-705 at 10 watts. If this is the normal way I operate, the only thing I should be concerned about is a solar panel and battery which can power my radio for the amount of time I'm going to work. So there's already a couple of facts we know about the 705 to help us choose. Firstly, at 10 watts, it's not going to pull more than 3 amps of current. And secondly, when I'm simply listening to the radio, it's not going to pull more than 250 milliamps. On this particular day, I planned on doing an awful lot of rag chewing on 17 meters. This usually includes an additional WinLink session to collect my email. So for these type of sessions, I generally deploy a 60-watt folding panel. That solar panel generates 3.6 amps in full midday sunlight. This means no matter how much power or how often I transmit, I'm never going to deplete my battery while operating in full sunlight. So with solar panels doing the heavy lifting, it gives me the option of reducing my load out by reducing my battery capacity. Here we begin to see the benefits of a lightweight solar panel over a heavier, higher capacity battery. When we start to think about overnight or long duration deployments, the battery pack and the chosen capacity becomes that much more critical. Think about it this way. During daylight, your station is completely powered by your solar panel. At night, the only thing keeping your station up and running is the capacity of your battery pack. There's also those times we'd like to keep a station up and running 24/7 throughout the deployment. We'll come back to that later in this series. Each of these battery packs is something we've built on the channel or a derivative of something we built on the channel. The most recent one is this one, a 2.5 amp hour lithium iron phosphate pack. Now, I've already done a build video on this and published it just before this video. So this may become an interesting pack for you, especially because the instructions are already there. Now this pack is going to be interesting for those who have a radio with an extremely low current consumption, something under 300 milliamps. It'll also be interesting for those of us who have radios with efficient transmit. Now here we are again looking at my Icom IC-705 and Microsoft Surface. The battery pack you see in the upper right hand corner of your screen is a 5 amp hour lithium iron phosphate battery pack we built on the channel a couple of years ago. Here you can see the radio and the battery pack along with the solar panel from a different perspective. Whether or not that solar panel is connected to the battery or not, the battery will still power the radio. This will remain true as long as the battery has some charge to offer. So the battery, the charge controller, and the solar panel all work together to ensure the battery is topped up and any load connected to the battery pulling current and capacity from the battery is replaced by the solar panel via the charge controller. So now let's talk about the first component in our pocket portable solar generator. That is the battery pack. So this is the smallest of the packs that I've built on the channel. I call this one the Ultra Pack. It's a 2.5 amp hour, 33 watt hour, portable and lightweight lithium iron phosphate pack. The benefits of this pack are its lightweight and small size. Don't let that fool you though. This pack can put out 30 amps through the BMS or a 50 amp load directly from the battery terminals. Obviously it's overbuilt. We're going to be using it for a QRP radio along with a solar panel. Now this 2.5 amp hour pack is great for these ultra efficient new portable radios we have on the market today, but it's not the only pack we can include in our portable power go kits. So the pack I just showed you is the 2.5 amp hour lithium iron phosphate. The next one is a 5 amp hour lithium iron phosphate, followed up by a 20 amp hour lithium iron phosphate, and then a 24 amp hour lithium iron phosphate pack. We choose these different packs based on the efficiency of our radios, the amount of time we're going to stay out in the field, the amount of sunlight available to us during our deployments, how long our battery packs need to power our equipment during the night, and the amount of duty cycle or demand we're placing on our radios. For example, the occasional WinLink session is far less power hungry than constantly putting out an FT-8 signal while fishing for a QSO. Now it's also important to keep in mind what radio you're using, its capabilities, and how much power it actually uses when it's transmitting at your chosen output level. Now some radios, both QRP and QRO, are more efficient than others. So before you pull the trigger on any battery or solar panel, you need to do the measurement we talked about in episode 1 to see just how efficient your radio actually is. Here are a few of the radios I've been using for testing during this series. The most efficient radio is by far the Lab599 TX500. That's followed up by the Icom IC-705, Elecraft KX2, and Elecraft KX3. Those are followed up by the Xiegu X6100, the G90, and the Yaesu FT-817 and 818. Now regarding QRO radios, there currently are no energy-efficient QRO radios which can be used portable on the market. Putting that Yaesu FT-891, 991 Alpha, or Icom IC-705 out in the field, off-grid for any significant amount of time, is going to add unnecessary weight and ultimately blow through our off-grid powering budget. There is an alternative to a QRO radio, however. That's a QRP radio and efficient amplifier. Now I say this because QRO radios are not efficient by design. This new generation of amplifiers like the LiFePO4 PA500 are by design extremely efficient, opening up more flexible portable powering options for the field. Anyway, that's enough about that. Now we've already talked about the battery packs. Then we took a detour to talk about radios and radio efficiency. But when we're talking about a portable solar power Go kit, we can't do so without talking about solar charge controllers. For QRP radios, I'm using a Genason GV5 or GV5 mod. The GV5 lithium and GV5 mod lithium are MPPT charge controllers for lithium iron phosphate batteries. They are small, lightweight, and have a 5 amp load port, which is perfect for most QRP radios on the market. The GV5 mod is a PCB version of the GV5 lithium. The GV5 mod is perfect for those of us who are looking for a ultra lightweight, ultra portable solution which we can integrate into some other larger project. It's also perfect for those of us who want to 3D print our own enclosure for the charge controller and battery pack into some sort of bespoke solution. Now we also have other charge controllers we've seen and used on the channel. The Genason GV10L, the Genason GV8 Boost, and something more recently, or something newer to the channel, is the Victron 7515, which we'll see as a part of this series. Now each one of these charge controllers solves a specific problem. The GV10 is very small, but has a 10 amp solar input. The GV8 Boost allows you to use a panel with low voltage to charge a battery with a higher voltage than the incoming voltage from the panel. Finally, the Victron 7510 allows you to place as many solar panels up to 75 volts in series to a maximum of 15 amps. Now for a man-portable QRP operator, these three are absolute overkill. Even so, we'll come back to these three charge controllers later in the series when we approach portable power for QRO stations. Alright, we started off with the battery packs, we went to charge controllers and made a detour in the radios, and now we end up at solar panels. Now I know when I say this I'm going to sound like some kind of corporate shill, but I assure you I don't get paid to recommend products. With that said, the three most common scenarios for choosing a solar panel are: I want to recharge my battery when my station is not in use. I'd like to increase my operating time without increasing the weight that I carry or the capacity of my batteries. Finally, I'm running either an emergency communication station or a de-expedition or contesting station out in the field. The station is critical and batteries must be replenished instantaneously or at the very worst, as quickly as possible. Now the 3 video clips up on the screen offer 3 examples of the type of solar power I deploy. Now in the lower left-hand corner, you see me with a crystalline panel. The reason for the crystalline panel is the higher voltage and, of course, greater efficiency. The higher voltage feeds my boost converter for the electric fat bike, charging my fat bike faster and more efficiently. It can also feed my charge controller and small lithium iron phosphate battery pack to power a QRP Plus or QRO station in the field. In the lower right-hand corner, I've deployed 2 100-watt folding panels. With this configuration, I'm able to deploy a WinLink gateway station or other IMCOM station, effectively replacing a diesel or gasoline generator with solar power and battery storage. It's not exactly a one-to-one replacement, as diesel generators run at night. On the flip side, as long as you have the sun, you can always power your station on solar power. Now in the upper right-hand corner, we have my basic QRP and QRP Plus station. I use a 60-watt power film solar panel, a 2.5 or 5 amp hour lithium iron phosphate pack, and a Guinness-on controller. Well, you remember earlier when I told you the 3 basic components of our portable power Go kit are a lithium iron phosphate battery, a charge controller, and a solar panel. From this point forward, we only have a few more things we need to make the station complete. That's power distribution, a computer if you use one, and of course your radio. In this video clip, you can see all 3 components of my high-capacity portable power Go kit. There's the charge controller, the 5 amp hour lithium iron phosphate battery, and when we raise altitude in our little camera copter here, you can see my 60-watt power film solar panel. This is the basis for my long-duration solar power Go kit. The 60-watt panel practically runs the station 100% during daylight. The 5 amp hour lithium iron phosphate battery keeps the station up and running during cloudy weather or at night when I'm not using the solar panel. Here's the long-duration solar Go kit, the 5 amp hour battery with the GV5 lithium. The size and weight of this solar Go kit is made possible by the flat 60-watt panel. When we do a side-by-side of the long-duration kit versus the fast field comms kit, you might not see very much difference, but actually, the battery pack is half the weight. Naturally, it's also half the capacity. The fast field comms kit is the one I generally carry with me when I'm on the fat bike. When you couple this high-speed low-drag kit with radios like the TX500, Elecraft KX2, KX3, or IC-705, we begin to realize some serious capacity gains because we're not carrying all of that crazy, unnecessary weight. So here we have it, the Icom IC-705, the power film 60-watt folding panel, the 2.5 amp hour lithium iron phosphate pack we built on the channel a couple of weeks before this video was published, and the Guinness-on charge controller, which I still need to wire up but hasn't been done for this video. For power distribution, I made a power pole adapter. It's got a power pole, single power pole on one side and 2 parallel power poles on the other side. I've also got an extension cord from the 60-watt panel and a power cable for the IC-705. This truly is the lightest, most capable man-portable solar Go kit we've done on the channel since we've started talking about solar power. Alright, before we close down this video, I want to thank PowerFilm Solar for supporting our quiz and giveaway in the first episode of this video. All of the winners received portable PowerFilm solar panels to help kick off their portable power Go kits. So you see, it pays to watch until the end of the video. But don't worry, I also have something for you. Both Gigaparts and Battery Hookup are supporting this video and this series. Gigaparts has all of the solar panels and charge controllers you've seen in this video. You can use my call sign as a discount code in their online shop. Now, if you'd like to DIY build your own lithium iron phosphate battery, you can do so with parts you get from Battery Hookup. You can also use my call sign at Battery Hookup for a small discount. And still, if battery building isn't your thing, check out the selection of lithium iron phosphate batteries from Gigaparts. They ship worldwide, they have a great selection, and they'll give you a discount with my call sign. Alright guys, I'll leave you with this. As you saw in this video, it isn't actually that difficult to build yourself a pocket portable solar generator for your QRP radio. All you really need is someone to explain why we should do it, and perhaps help you get it done. Let me know what you think. And with that, if you like what I'm doing, if you like the content I'm sharing, please leave me a comment and or a thumbs up to let me know. And if it's not too much to ask, please share this video with someone or someplace where other operators might enjoy it. Rock and roll, guys. Thanks for watching. Ciao.